Welcome! In this video, we are going to look at image formation by mirrors. Let's start with the variables for curved mirrors. We have capital R as the radius of curvature, capital F is the focus, lowercase f is the focal length, which is the distance from the mirror to the focus, DO is the object distance, which is the distance from the mirror to the object, and DI is the image distance, which is the distance from the mirror to the image. There are a few conventions or assumptions for lenses and mirrors. First is that light is incident from the left. Next is that objects are in front, meaning on the left. And lastly, the objects are upright. Mirrors can make real images and virtual images. A real image is in front of the mirror or behind the lens. It has a positive image distance and it is inverted with respect to the object. A virtual image can't be formed on a screen. It is behind the mirror or in front of a lens. The image distance is negative, and the virtual image has the same orientation as the object. We usually call this upright, as we assume we start with an upright object. Plane mirrors form virtual images. They appear to be behind the mirror. The image distance is the same distance away from the mirror as the object, and it is negative. The image height and object height are the same. Concave mirrors can form real images with positive image distance, and they can form virtual images with negative image distance. The radius of curvature is on the real side, meaning the side that light is incident on, and this gives a positive focal length. Convex mirrors can only form virtual images, and so DI is negative. The radius of curvature is behind the mirror, which we can refer to as the virtual side. This gives a negative focal length as light does not reach this side. We can use ray tracing to locate images. There are 3 rays and an optical axis, which is a horizontal line that goes through the middle of the mirror so that half the mirror is above the axis and half is below. For concave mirrors, ray 1 goes parallel to the optical axis and reflects through the focal point. Ray 2 goes from the object to the center of the mirror and reflects back at the same angle. Ray 3 goes from the object to the focal point and reflects parallel to the optical axis. The intersection point of the rays locates the image. The figure is from College Physics 2E by OpenStax, and it shows the 3 principal rays for a concave mirror. There are 3 principal rays for convex mirrors as well. The first ray is parallel to the axis and seems to reflect from the focal point behind the mirror. Ray 2 is the same as for a concave mirror. A ray striking the center reflects back at the same angle. Finally, ray 3 heads toward the focal point behind the mirror and seems to reflect parallel to the optical axis. The figure is from College Physics 2E by OpenStax, and it shows the 3 principal rays for a convex mirror. I hope you found this helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.